We're in business, right? Did I start my countdown timer? No, I didn't. That was a bit remiss of me. Right, thank you very much and welcome. What I'm going to try and do is dispel the myth that regular expressions or regex or regex, which way do we pronounce it? It's a bit like GIF and GIF in that it really doesn't matter. You just need to use them. And I'm just going to try and convince you that they are actually pretty straightforward to use. They don't have to be brain-blowing. You don't have to be a rocket scientist to understand them. So let's crack on. Hopefully, hopefully, what do I mean hopefully? It's going to be lots of live demos because that's the only kind of demo there is. Dead demos don't quite work the same, so that seems to be habitual. We'll do the who am I slide. Oh, I've left it blank. Okay, well, I'm just me. Developer, PowerShell person, troubleshooter, old man, grandfather. Okay, so what is a regular expression? Well, it's a search / matching pattern, but unlike pattern matching, and we're going to focus on PowerShell here, but again, regular expressions are pretty widespread, and as we'll see in this on this particular slide. So it originated in 1951. So Carl Webster had only been in the business for about 20 years. Actually, before my time, I only started using regular expressions in 1988, so I'm a relatively newcomer to them. I'm going to say used in many programming languages, PowerShell ISE, but I've started using Visual Studio Code. If you've seen any of my tweets this week, because I have to now, I'm starting to use PowerShell 7 more. Good old Perl. VI, yes, I know how to quit VI. And the sad thing is I can't remember why I walked into a room, but I can remember a lot of the commands I was using for VI in the late 80s and early 90s when I was using green screens to write C++ code for Unix systems. Oh, those were the days. Even Finestra, if you used a legacy CMD, that has regular expression support built in. Good old Notepad++, of course, and many, many more. So we're going to use it here in PowerShell, but only because that's very easy to demonstrate. You know, I could use it in C#, then I'd have to compile code and so on. So I'll just use it within PowerShell for the demonstrations. And you think, okay, well, PowerShell, that is quite easy to use. We'll see how easy it is to match. But these regular expressions, they're quite scary, aren't they? Well, you've seen one regular expression already. In fact, you've seen a lot of regular expressions. So if I search my history for my demo, which I've been preparing for, so I use Control-R in PowerShell to search, and I'm going to search for the word fear. Then we're going to say, please don't fear the regex, as they aren't that scary. Does that match don't fear the regex? Where the regex or regex, I switch between the two, is don't fear the regex. And does that match? Yes, it does. So there you go. There's a regex. What's the regex that matches Guy? Guess what? It's Guy. And the beauty of PowerShell is that by default, it's even case insensitive. That sometimes can catch you out and make regular expressions a bit more difficult because you have to specify both lower and uppercase, but by default, PowerShell at least is case independent for its regular expressions, but we can make them case sensitive if we want to. There are a number of subtly different implementations. It won't matter for the stuff I'm going through today, but some of the more esoteric, more complicated ones, which I very rarely use, and if I do, I have to look them up. I have to RTFM as much as anybody else. They're the ones that differ slightly, but don't let that worry you. Certainly don't let that put you off. Okay, why are we going to use them? Oh, to find some text. That's usually the reason for it. So a global search and replace, that's where I used to use it in good old VI back in the 80s if I wanted to change something. The reason we use it a lot is checking of log files. So rather than having to just wade through them or grep them or find-str them or select string them, which is, although there is an alias grep for that in PowerShell, we can actually tokenize them and pull some out. I was using that to pull some actual JSON out of a log file the other day and display it as JSON. We can validate input to make sure the input is actually what we're expecting so that we can throw errors or prompt the user to input again or tell them not to be so stupid. We can get specific bits from strings, from text, so we can start to tokenize them. or we can do the replace side of things, insert some stuff, so we can do automated editing of text files, INI files. I'm sure we all use applications, unfortunately, despite this move to SaaS and everything else, that use good old INI files. Tokenizing is something I'll come back to because that's what I use it a lot for. By tokenizing, I mean splitting into elements, where quite often you might use minus split and minus replace, and that actually, to me, gets more messy and more difficult to understand than using regular expressions. You can use minus like, minus not like, which uses standard wildcards like you'd have in legacy CMD with things like the dir command. So star that matches anything, a question mark, that is a question mark in this bizarre font, that matches a single character, and square brackets, which is a range, A to M or A-Z or A-Z for my American people. Okay, so let's look at some basic regular expression building blocks. So some very, very simple ones. And to be honest, I don't use much other than the basics. I'll show you a couple of real life regular expressions in a bit, which hopefully won't scare you. Because we can use the simple stuff. Some people might come back and go, actually, you can do it this way. And I did that. I had that on a tweet a couple of weeks ago. Somebody said, oh yeah, but you ought to do this and you ought to do that. And then suddenly the regular expression becomes very difficult to understand. But the point is I tested it and it worked for my use case. So we've got some special characters such as dot, which is a bit like the question mark in a wildcard where dot matches any character. So does Fred match dot? Yes, because dot will match the F. Star, unlike a wildcard, star means any character. Star is actually a qualifier. What it means is 0 or more occurrences of what came previously. But hold on, what's a \D? There's no \D there. Well, \D is a shorthand for any digit. So what you've got, and if I was at home, I'd show you in my office, I've got a cheat sheet of these escape sequences like \D, \W, \B, which I'll come to. And then if you actually need to have a real character, so you want to match a backslash, how do I do that? Well, you do \, because you have to escape it. Okay, so is that starting to get complicated? Am I starting to lose people? Hopefully not. So let's have a look at, let's have a look at that one. So we can say, what should we do? That one. 2, 3, 4, 5. Let's do a live demo where I'm not copying what's exactly on the screen. Again, types of quotes don't really matter. Remember that single quotes in PowerShell means it's not going to expand. So if there's any dollar variables, it's not going to try and expand them, which is important when we come to showing usage of replace later. And that matches it because \D is just shorthand for any digit. I could actually have used a range 0 to 9. Yeah, or I could have put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 3 different regular expressions all matching the same thing. Again, there's no necessarily no right or wrong. Those will probably differ very slightly in their timings, but unless you're running them a million times very quickly, it doesn't really matter. Yeah, do what is most readable, and that's one of my points later on. And this slide deck will be made available later because it's kind of an education deck as well, so hopefully will help you. Plus, and then yes, I've that should say plus in there, not star. Well done, Guy. When you copy and paste, remember to change things. Plus means 1 or more, subtly different to star. So star kind of means, or asterisk, optional. So 0, it could be 0 occurrences of it. Plus means 1 or more, so there must be at least 1. And sorry, I'll correct that in slide deck before I push it out. But in reality, there's usually very little difference, but it sometimes can catch you out. So understand what the difference is. I tend to use plus when I definitely want 1. Question mark, unlike in wildcards, is optional. So in this regular expression, we have does plural match plural, and the S, because the question mark qualifies the S is optional. So we can say, let's see if I've got this one. Did I do this one? I'm not sure if I did this one before. No, I didn't. Okay, so plural minus match, again, tab completion, of course, plurals, question mark. Does it match? Yes, it does. Why? Because the S is optional, yeah? So we could use that for matching HTTP or HTTPS, of course. So HTTP, Does that match plurals? No, it doesn't. Of course it doesn't. Even we can see that. HTTPS question mark. Yes, as does HTTPS. Yeah. What if I want to see if it's a URL? Well, I could go, that's not a URL, but I could put in bbc.co.uk/iPlayer. That does match. Yeah. So I notice I've not had to put any backslashes or anything clever in there because none of these characters here are special characters, so I don't have to escape them. You could escape them if you wanted to. So you could put, but again, and that's true, but that then makes it very difficult to understand. So again, only escape things if you have to. Do I have to escape them or not? Test it. You know, there are plenty of regular expression online checkers on the web, regex101.com and so on, but I don't use those. I just use PowerShell here. Yeah, interactively, it does it all for me. Then we're getting a few what we call anchors with an A, yes? So the caret or hat character or whatever you want to call it, that matches at the start of the line, yeah? So if I want to match, my name is Earl, no, Guy, minus match, I want to match Guy at the start of the line, I put the caret character in. How's the font size, by the way? I'll blow it up a little bit. Again, because I'm using Windows Terminal, I can just use Control+ to zoom that in, because Guy isn't at the start of the line. But if I change it to my, for instance, without double Y, then it's true because the caret says match from the start of the line. This is where it gets a little bit confusing sometimes, and we'll see this in a couple of regexes I'm going to show. In the inside square brackets, the caret character means not. So where we saw, actually let's clear the screen so there's not lots of confusing stuff on there. So if I look for something which is square bracketing, I could, if I put a not in there, 0 to 9, that means that doesn't match, or rather it matches if there's not digits in it. Yeah. Why is that matched? Oh yeah, okay. What have you matched? Well, I'll, yeah. Don't you love live demos? Anyway, we'll come back to that. And dollar is the same, but the end of line. And beware of arrays. Where did I put that? It must have been a good idea at the time. And yes, beware of arrays. Okay. Why did a programmer quit the company? Because he didn't get arrays. Boom, boom. Okay, I'll put a comment in that when I remember why I wrote that. Don't get old, yeah, you lose your memory, or at least I think I do, I can't remember. Then a couple of other building blocks. We can have a count. So an easier way of doing what we did before is we could say \d and then the squiggly brackets, 2, 4. So between 2 and 4 digits will match. So if I'm looking for an error code, and I know that error code is always at least 2 digits long, I could, but no more than 4, I could put 2, 4. Again, only do that if you're absolutely certain that that will match. This makes it much easier. So I can say my surname, does it match Leach or Smith or Jones? I don't have to do anything clever there. You know, very easy. Those are just literal strings. As we saw earlier, you know, if I want a regular expression to match my surname Leach, then I just have the string Leach. That is a regular expression. I don't need any dots or stars or backslashes. Yeah. So keep it simple. Always keep it simple. And I think that's part of the problem for people who know regex, is that sometimes they'll go online and try and show off with complex regex, make it very obfuscated and difficult to understand. Sometimes I'll see regex and I won't understand it. But the way to do it is to do it bit by bit. But again, I'll give you some of my hints and tips about how we manage that later on. So again, square brackets are kind of introduced already. So that's a range. So we can see in that first one, bit matches B, and then any of the characters A, E, I, O, U, or what we call vowels, that matches, or B, A to Z. So BRT, BST would match because I've said anything A to Z. Yep, so it can be a range or specific characters, and they don't have to be the same characters, and we'll see that in some regular expressions later on. Then a couple of the main backslash escaped special characters you'll come across. We've seen \d already. \s is white space, which also includes a tab character. This is one of the things that can trip you up, particularly in parsing log files. Is a tab and a space are different characters, but \s will actually match either of those. Although you can use a space in your regular expression. Think back to the first example I gave you where I was saying don't fear the regex. I was using spaces in there, not \s. Again, makes it more readable. So if you don't think there's going to be a tab, just use a space character. Yeah, makes it easier to read in my opinion. /w is a word character, so but that can be alphanumeric, so it's not just alphabetic. And then we've got /b for a word boundary. What do I mean by a word boundary? Well, I mean, if we're looking for the word, let's have a look. I think I did these earlier. No, okay. Okay, guy, how's a thought? If you're searching for a \b, why not search a \b? Okay. That's a good idea, isn't it? Yes, and now I've lost my search term. Control-R to search, \b, Control-R to search again. Where's that one I want? Okay, so here we go, for instance. So if I say, does Fred match \b means red at the start of the word and \b means at the end of the word. So does Fred match that? No. And notice I've got a C match, which is case sensitive match. So red does match it, but red doesn't. And then if I try and cursor up, if I go redder, that doesn't match it either because the \b means I'm looking for that exact word red. So I'd use that quite a lot to make sure I'm not picking up a substring. So that one's quite useful. Again, you don't have to worry too much then about what spaces are surrounding it either. Okay, so here's some examples, from real life. Yes, that thing. There's a regular expression that matches Windows 10. Yeah, it's pretty easy, isn't it? Remember when we're using these, we'll probably put quotes around them in PowerShell. I've left those out just to make it simpler. So you can see here when I was using the regular expressions, I was just putting quotes around. Again, single or double doesn't matter really unless you've got things that want to be expanded like dollar expressions, dollar variables. So there we're using the \b that I was just talking about in terms of the word boundaries. So that matches the word error. Now, will that match it? If I know my error log files are always going to have it in capital letters, then I would have to use a C match because by default, as we said in PowerShell, they're case insensitive, which a lot of the time makes it a lot easier. But we've got C match, which is case sensitive. We've also got, if you want it, I match, which is insensitive. So you're explicitly saying I match. So you're saying I don't care about the case because you might have the word error in lowercase somewhere else on a line, which might even be an info line saying error handling has been set up successfully, where that error would be in lowercase. So we can be case sensitive if we want. And what does isolate the error code here? Well, I'm jumping ahead a little bit, but I'm using one of the most powerful features of Regex, and certainly how I use it for tokenizing a lot of stuff are these parentheses. Because what parentheses do is to group your regular expression matches. So see, we've got this built-in, let's move that out of the way, error has occurred. If I could spell, who cares if I can't? We have this built-in variable called $matches, which will tell you what has matched. It's actually a hash table, not an array, which sometimes people make the mistake of thinking that, and we'll see why. But what I can do here, so if I use this example here, so if I say Let's have a look. There we go. That's actually a bit more complicated than I want. So that's the example we've got here, case insensitive, error 5 whilst loading 32 ducks. An error message I'm sure you've seen many times in your own programs. So first of all, does it match? Yes, it does. Let's have a look at the regular expression. So I'm looking for the word error on its own, so not part of any other word, because I've got the word boundary \b around it. Then followed by any character, which is the dot. Star means 0 or more, so that means 0 or more of anything whatsoever. The parentheses, as I say, this groups stuff together, so it's not looking for an actual parentheses and opening bracket. If I wanted to look for an opening bracket, then I would do that to escape it, and similarly that for the closing one to escape it. So those are being used to group. As we've seen already, \d is a digit, so that means 1 or more digits, not 0, 1 or more digits. And that has matched, it tells me that's true. So let's have a look at our matches built-in variable. So that's always there in Windows PowerShell and PowerShell 7 for that matter. I'm doing this in PowerShell 7 actually. I'm not using a lot of PowerShell 7 for my customers, but I'm trying to use it more and more now. So this is PowerShell 7. But in terms of all the regular expression stuff at the moment, what I'll show you is exactly the same in PowerShell 5 or 2 upwards for that matter. I've done about 1 because I've not really used it. But, so let's have a look at the $matches variable. And what we can see now is we've got 2 matches. Matches 0 is always the whole match, nothing but the match, so everything that's matched. And then starting from the left, this is match number 1. So unlike arrays where we start numbering at 0, the actual grouped matches, so those which are in parentheses, start at 1. So that's actually matches 1. And as I said, this is actually a hash table. So rather than using round brackets, parentheses, to look at an index, I actually have to look at the key itself, which actually happens to be a number 1. But we'll talk about named matches later. So that's the match. So that's what I mean by isolate the error message. So I've used that. So I can now use that. Notice it's 2 as well, because what we'll see is that it's eager matching. The dot star has actually consumed the 3 there. So we have to actually do a different regular expression, which I think I've got in here. So look. Yeah. So let's have a look here and see how this one works. Yeah, so that's matching the first code. So you see that my regular expression wasn't actually right because I was matching the 2, which is there, which actually isn't the error code, because I know the error comes straight after the error text. Yeah. So this new regular expression, again, we're looking for error. That's not any different. We're using the square brackets, which is any character. But what we actually, should I just move that up slightly? Then you can see the translation. Well, translation from English to English. Yes, probably don't understand my dialect. So what we're saying here is, so square brackets is a range so I've only got 1 character in the range, which is a \d, so that's a digit. But what I'm saying, because what I'm looking for here is basically I'm looking for error, and then I'm looking for a number. So what I'm looking for is error with its word boundaries, the \b's, and then I'm looking, remember this is where the character takes on its other meaning when it's inside square brackets, as per a couple of slides ago, where this says not. So I'm saying it's followed by 1 or more, that's the plus, of something which is not a digit. Yeah. So the square brackets is a range, but I've only got 1 thing in that range because that's how I negate it. Yeah, negate caret outside of square brackets is begin at start a line. So if I use the caret there, it wouldn't match. So now I've said match 1 or more match 1 or more some things which aren't digits, and then match 1 or more digits. So error followed by something which isn't a digit, and then a digit. And that's what gives us the correct match. So the problem with regular expressions is they're what's called greedy. And in this example, what's happening is the dot star is consuming everything up to that number 2. Yeah, that's all the \d is getting. So you have to be a bit careful with these, which is why I tend to use this construct, the square brackets with a not, a lot. And we'll come across that again in another example on this very slide. So that's me checking the input from asking the user, what do they want to proceed, yes or no, via, let's say, a read host in PowerShell or through a WPF GUI. What's that matching? Well, again, if I had a live audience, which is generally more entertaining than a dead audience, then I would ask people to tell me what that was. And that matches a drive letter. So this is a square bracket. Oops, sorry, gone too far with fat fingers. So the caret there means begin at start of line because it's not inside square brackets. A to Z is a range. And then I'm matching a colon, and then I'm matching a backslash. But remember, a backslash is a special character, so I have to escape it. So that will match any path. So if I'm trying to check if a path is absolute, then I can say, does the path that I've got from somewhere match that? Whereas if I want to match a UNC, it's like, whoa, hold on, guy, what's all that about? That matches UNC. How does that work? Okay, so again, caret, start a line, so start matching at the start of the string. Backslash is an escaped backslash, followed by another one, so that's 2 backslashes. And if we know a UNC is backslash server backslash Fred. So it's going to be backslash something. Now, has it got characters, underscores, dashes, numbers? It could have all of those, but one thing it won't have is a backslash. So this is what I was saying before a couple of minutes ago. So that now I've got a range, which again is only one character, which is a backslash, but escaped because the backslash itself is a special character. So I'm saying one or more of anything which isn't a backslash. So that would match the slash server 1 bit before it got to the backslash. Then I want to match another backslash. And you think, okay, guy, yeah, I believe you, honest, thousands wouldn't. Okay, well, again, let's do a live demo. Let's see if I've got one I prepared earlier. No, I haven't. That's good, isn't it? Oh, actually, yeah, I have. That was one, silly boy. It was a real life example on my NAS at home. So there we can see the regular expression. It's going to match 2 slashes, which is there. It's going to match everything which isn't a slash, a backslash. Yeah, so caret means not backslash. So that's going to match my GRL NAS02. So I've not had to worry about whether it's alphanumeric or anything like that, followed by a backslash. And now I'm using grouping as well, and we'll see that in the results. And then after the backslash, so the software, app-v packages, Chrome latest, etc., is all going to match that. And then I've put dollar in. I don't technically need to here, but I always think it helps clarify a regular expression. You're saying, yes, I really do want it to match at the end of the line. But as I said previously on the last example, that they are eager and that it would match the end of the line anyway. So let's do that. So that's true. Let's have a look at the matches hash table. I nearly said array. So you can see here's my first grouped expression because I've used the parentheses around it. So I'm not matching parentheses. There's no parentheses or brackets in this string that I'm matching at all. So that says this is going to be the first match because it's the first grouping, the first parenthesized even part of that string. And the second bit is this one here. So it says just match everything after that first backslash. So this is here. So I've now managed to isolate the server where the share is held and the actual path on that server. Now I could have done it again with another, I could do it another way if you wanted to, because there's a share and then there's a folder. So what we could do is do this again. Actually, I'm just going to remove an element from this so that it doesn't wrap. Yeah. And then we'll say, okay, well, it's going to be actually followed by this again, because again, it's no backslash, then a backslash, and then the actual directory path. So does that match? Yeah, don't you love live demos? Phew, I might actually know what I'm talking about. No. Yeah, so now I've actually split that into 3 tokens. So I've split the server name, the share name, and the actual path on that share, just using regular expressions. You look at that and you go, oh my God, that's why I hate regular expressions. That's the mark of the devil. Now you just have to calm down, dear, and read it, yeah? Start of line, a backslash, followed by a backslash. A grouping element, so we're not actually looking for a parentheses, square bracket meaning a range, caret, special meaning inside that meaning not, so we're looking for not for a backslash, 1 or more of those, followed by a backslash, followed by 1 or more of something which isn't a backslash, followed by a backslash, followed by anything we damn well please. And that just breaks it up, yeah? So that, and when I'm building a regular expression, that's the way I'll do it. I'll build it up bit by bit. Let's match this bit first and look at matches variable. Let's add the next bit and so on. Just do, trial and error, I suppose, is the way to do it. I don't always get regular expressions right first time. Yeah, so that was the second one I showed. Obviously, I haven't got the third one on there, which matches the server, the share, and the folder. And then here's another one from hell. It's like, what are you doing there, guy? What the hell is that? Now, I'd ask for hands in the audience if we're doing this live, and somebody would go, that's a GUID. A GUID, what's a GUID? A GUID is what you get when you go to Stonehenge on the summer equinox. No, it's not. That's a Druid guy. Oh, sorry. Very English joke there. That's a GUID, yeah? This is also a good way to create random file names if you need to, or random data. It's a GUID with that number of characters should be pretty unique. So that's a GUID. What we mean there is that's 2, 4, 6, 8 characters, followed by 4, followed by 4, followed by 4, followed by 12, which is exactly what we've got here. It's a range. It's a hex digit, 0 to 9, A to F. It's got to be a hex digit. 8 of those, exactly 8 of those, a dash. I don't have to escape the dash because it's not special use case outside of square brackets. 4 digits, 4 hex digits, 4 hex digits, 4 hex digits, 12 hex digits. Yeah, and now I'm matching a GUID. Yeah, easy. Yeah, easy. Yeah, it is, honestly. Don't be frightened. Let's all take a deep breath. Regular expressions are easy. Keep telling yourself, regular expressions are easy. As I have one of the dogs in the room looking at me like I've gone mad. Well, perhaps I have, but nice day for it. Okay, so some regular expressions in PowerShell. Where can we use them? Well, we've seen match or minus match once or twice. I've introduced case-sensitive match, case-insensitive match. There's also not match as well. Don't overlook these. And then we've got split and replace. And they're case sensitive and in case explicitly case insensitive versions as well. But again, they're case insensitive by default. So minus split will split based on a regular expression, unlike the split method. And then we've got the replace, which again, I use a lot when I'm tidying up strings, and we'll use some real life examples in a moment. Don't specify the replacement, delete the match text. Hopefully that speaks for itself. And again, not the replace method. So what I mean by that is you've got 2 ways of replacing. So we can say Guy Leach is cool. Yeah, right. Minus replace cool, which is his regular expression, of course. Not cool. Yeah. But if we said C A to Z, cool, backslash B, so let's put some word boundaries in there. Yeah, what's my deliberate mistake there is I've only specified 1 character, haven't I? Yeah, so I've only said it's got to be C some letter between A to Z followed by L. So it would match COL. I don't believe you. We think you're lying. Okay, I'll prove it. Yeah. Whereas if I then specify a plus, yeah, Guy Leach is not cool because the plus means one or more. So that's matched COO. Yeah, but if I try and, there is a replace method for a string. So I can just, because that's a string, I can go dot replace, because it's a method, I use parentheses. Yeah, so dot replace doesn't understand regular expressions. Dot replace understands wildcards, which are star, question mark, and square brackets for a simple range, but it doesn't understand a plus, and it doesn't understand backslash b's. It would be looking for a backslash b. Data store path, and I actually want to convert it to a PS drive path. I'll show you what I mean by a PS drive path in a moment now. As long as I've got $DC set in this session. Again, this is an example of where I'm using replace with groups. So again, remember we had groups which were in that matches. Well, with minus replace doesn't have matches per se, but the first parenthesized item is $1. The second parenthesized item is $2. But because this is in double quotes, which expands strings, because I'm using a variable within here, I've actually had to escape using PowerShell's string escape character, the backtick, to escape the dollar so that it doesn't try and evaluate.
Did we lose you, Guy? Yeah, Dave, it's gone here as well. Seems like his connection freezed up. Is he coming back? Are you there, Guy?
Do something.
Yeah, there you are back.
Phew, that's my son's fantastic wireless, which is, and his broadband is much faster than mine, but it's not as reliable. But I do have my 4G router, which I was about to switch to. So I don't know how much of that you got. So what I'm saying here is the range. So I'm trying to match either a word character such as local or SSD, or a space, one or more of those. So that's my data store name, followed by anything, but that's inside the parentheses again. So that's going to be my second replacement. So what would be in dollar matches 2? So that's what $1 and $2. And of course, $DC has been set, which is, your guess is Wakefield, which is the name of my data center, because it's sat in my garage at home in Wakefield, West Yorkshire, England, Earth. So that's how we're using replace with grouping to actually replace things. Because I see a lot of people sort of matching things and then trying to replace bits with split and everything else. And to me, it gets quite ugly. So let's move that out of the way, down to the last 5 minutes, thanks to my PowerShell timer. This again is available in GitHub. I find it very useful timing things, but also making a note of when something specific happened. Okay, so let's crack on as I'm running out of time. There are some, so those are operators that I use as we saw either in scripts or immediately as I was using that PowerShell window. Then we actually have some built-in commandlets, so PowerShell commands if you like. Select string, which is an alias SLS, which is case insensitive by default. Put a couple of tweets out on that today because I found some quite useful features in PowerShell 7 that helps you decide whether your regular expression is working and how much of it is working. And again, we can use grouping and matches inside that as well. You know, if we pipe into it for each object and so on. So that can be a quick way of parsing a log file. Some statements. So if you've got a switch statement in PowerShell, you can switch minus regex, optionally with minus case sensitive to match on a regular expression. And lots of scripts. As I said before, it's much more flexible than minus like. And the PowerShell ones are compatible with Perl version 5. Hey, hallelujah. Okay, so I'm going to skip through this pretty quickly because I have already introduced this dollar matches, so we've seen how that works. So we've seen that first example already in action. The second example here is where I'm saying match anything, which is anything but white space or a hash. So what I'm trying to do here is find, so this might be a list of machines in a file, and what that will do, I'm going to do a demo because of the shortness of time, that will match just machine 1 because I've said match anything that doesn't match \s, so white space, so a tab or a space character or a hash character. Matches one or more of those, I could actually do without the plus there because that would stop at the first character that didn't match a machine name. Yeah, so I couldn't have a space in the machine name, for instance. So that's, if I ever accept text input from a file with, containing a list of something, then I'll generally use this regular expression to filter it so that people can put comments in the files because I'm nice like that. We can actually use named groups, and this can make the regular expressions look a little bit more difficult to understand. But afterwards, it's easier to use them. If you've got a line with lots of parentheses, so lots of matches, so you've got matches 1, 2, 3, 4, and 5, and you've got to remember what 1, 2, 3, 4, and 5 are, it can get a bit painful and not very intuitive when you look at the code. So we can use named matches. Hopefully I've got some examples of those somewhere. Yeah, there we go. So here's the previous example of that VMware data store being matched. So what I've got there is the question mark and then the name of the match in these less than greater than chevrons or whatever you want to call them. So similar to the previous regular expression, but this time what I'm doing, this question mark less than data store greater than is naming that match. So I can actually refer to $matches data store as a string later, or $matches file name as a string. Let me just see if I've got any examples already rolled. There we go. Okay, fortunately, good old Control R. So again, that's the example on the slide. So I've got a group because I've got the parentheses, but I'm saying that match is actually going to be called data store, and that matches space or word character. So let's run that. And let's have a look at $matches now. So rather than matches 1 and matches 2, I've got matches data store and matches file name because I named them. So that makes the regular expression look, particularly for people who aren't used to name matches, pretty help. But it can help you later on, particularly if you're matching a lot in a particular string. So you might be matching a date at the start, date stamp, date and time, followed by status, error, info, warning, debug, etc., followed by the line. So that can allow us to name those rather than having to use matches 1, 2, and 3. Personal choice, really. I don't use named matches very much, mainly because I'll put a comment where I'm going to put the code. This is definitely something I want to show you how we use these in real life. So I'm actually going to show you Visual Studio Code that I've started using. So there's a potentially fiendish regular expression. Okay, the quotes aren't part of it because that's just because it's a string. But again, we already know that I'm using a caret to say start of line, dollar end of line, so that makes it simple already. I'm actually looking for a less than, because what have I done here? This is what I've done. I've put an example of the regular expression that I'm matching above where I'm matching it. Yeah, so that's the sort of string that would come in here, and these caret characters here in the comment, this is the bit I'm trying to isolate. So you can see here, I've got a group. So that's matching anything after what? Well, after a less than, which is that character there, followed by anything which isn't a greater than. So that will match everything up to there. Yeah, so I'm saying not greater than. Again, I put the backslash in to escape it. One or more of those. Then the bit I am actually looking for, so it's dot star, because I'm looking for everything. And then I'm looking for another less than, followed by a forward slash, followed by anything, and then a greater than at the end. So that last bit here is matching that. Yeah, scary? No, please don't tell me that's scary. You just need to think about it, yeah? And when I'm building these up in scripts, then I do it bit by bit. Yes, my countdown timer has expired and I know it's time for me to shut up. So hopefully that was useful.
2 minutes, you're good.
Oh, I've got 2 more minutes. Oh, fantastic. I love you, Eric. Let's move that out of the way. I was trying to keep the time, but again, I didn't get through half the stuff I meant to get through, but in 45 minutes, you can't really even do a introduction to it. So I would say we can also use the name groups, well, not the named groups, but we can also use grouping, as we saw with the $1 and $2, as I've already shown in that example. So some tips and tricks. So remember before I showed you what some of you might have been a very frightening regular expression, but I can actually just define that as a variable. And then when I come to do the matching, I can say a log line with a GUID. Of course, because I'm inside the double quotes, that will expand GUID to that. So you can actually define your horrible regular expressions as variables and then just say match a GUID with a number, dollar number, yeah. Matches, I can't stress enough how much this is useful, but remember it's a hash table, not a dictionary, which means you use square brackets to address it, look it up rather than round brackets effectively. So do it bit by bit and test it interactively. You know, so I'm saying if that matches, then show me the matches. Because one of the things that you'll find is if something doesn't match. So let's have a quick demo. I'm going to keep talking till Eric shoots me. Fred minus match blogs. No, it doesn't. That's false. Dollar matches. What? Because dollar match, because it didn't match, dollar match is still there from the previous one. Yeah. So make sure that you really are matching before you start using dollar matches. Otherwise, you'll get into a bit of a mess. Again, so I was talking about tokenizing. I can split up a string very easily, very quickly, without having to use minus split, minus replace, all that sort of malarkey. I can just say, does it match? And then once I've used the match, I can then use those matches later on. So let's just have a look for a quick minus match in here. There we go. There's me using numbered matches 2, 3, and 1. I don't have to use them in the same order. Yeah, so I'm splitting a path using the dollar matches variable once I've matched it. Very easy to use. As we saw in my Visual Studio code there.
I think if we let the guy keep on talking, you're gonna talk you into sleep talking Regex here on Friday night.
I'll keep everybody awake. It's such an exciting, brilliant topic. Can't you get my enthusiasm? Well, the slides will be there. There's only a couple of slides left, but obviously I've run out of time.
Yeah, excellent. You just send me the slide deck, and I will attach it to the video replay, if that's
cool.
okay.
Oh, absolutely. Well, I hope that's been useful, folks. Feel free to ping me on Twitter if you've got any questions. Thank you very much, Eric.
Thank you, guy. And with that,